choose the same symbols. There's a modulating voltage. Okay, that to make different, I'll put it. Modulating signal, this is carrier signal. So what is this modulating signal? Frequency of this is how much? Audio frequency. And this is a carrier signal or carrier wave. I'm going to amplitude modulate it. The amplitude of carrier should change. So where is the carrier now? Amplitude of carrier, where it is available here, no? So this should vary as that of modulating signal. Therefore, the amplitude modulated wave will be of nature E is equal to the amplitude of carrier. So I'll put it, should vary as that of modulating signal. So what is modulating signal? AM sine omega t. So the amplitude modulated wave is given by A into sine omega ct. VAM, what is this? AM wave, amplitude modulated wave. Is it okay? I'll write in short. Okay, let's substitute this one. Okay, let's expand this. This will become AC what is Vm from the first equation should be sine omega AC is missing here. AC AM sine omega t let me take AC common.
Will not get AC, sir.
Okay, we don't get AC.
Second term AC will not.
Okay, I'll remove it. AC, so this will be sine.
Can't take AC common.
Let me take common. What is there? So this quantity, let me call that as mu, called as modulation index. Sine omega ct omega m. I'm just adjusted things. Now let me expand it. Mu AC sine omega ct. Now what is mu? Mu is called as modulation index. It is equal to amplitude of modulating signal by carrier. This is theoretical on paper. That particular ratio is something very important, theoretical. Let me go for sinusoidal expansion of this. This I'll end up AC sine omega c. 2 I'll adjust it. Okay, there's a trigonometry which we can manage very easily. 2 sine c sine d formula. I'm going to write this as cos of omega c minus omega mt plus okay, fine. So these are the 3 components I got. So this is what? Amplitude modulated wave. And this is what? Carrier wave. This is called as lower sideband. This is upper sideband. I got components. Final. It's a just theoretical proposal. I'm putting it. Sir, how do you modulate? I'll bring the circuit later on. Just let's analyze mathematically here. So this called like upper sideband, lower sideband, carrier waves, or something what you are doing here. So let's go for the spectrum. So what is the spectrum? The frequency spectrum it is called as. So there's a carrier wave, and there's a modulating signal. It will be, now frequency spectrum. I'm showing it. Okay, this is FM. You write like this. This is FC. What do the length of arrow? Length of arrow indicates the amplitude one. Uh, so the final, these are the two things. I'm going to superimpose. See what I did superposition only. But what is this superposition? So like something you should add up VM plus VC. Yes, I can't do this. We don't have any equipment which will do this. This is a mathematical proposal. What you suggest is like, sir, like a VM plus VM is equal to VM plus VC only. I'm going to do it. But I don't get VM. I'll get several components. Then I'll do further mathematical operations. So there's only on paper mathematical proposal. Okay, like this, we can do it. Okay, next question comes. What is that amplitude modulator? Where it is available? When you superimpose both this and finally do it, no? So you'll get the same information available here. Twice it will be available. This is FC minus FM. This is called like a upper sideband, lower sideband. There's a carrier wave. And what is this? Modulating signal. So there's a song. Let's assume that it's a song. What is the modulating signal? Song. It has to be transmitted. The same song is available in carrier at two frequencies. Sir, which frequency I should use? It's left to you. Because you want to hear the song, no, that's one. You can pick up, you adjust in your radio set the frequency of the tuner circuit, either to this frequency or this frequency, you are going to hear it. Sir, why you are showing two? Because I have no the information. Because what is this? Here the information available in carrier at two frequencies, upper and sideband. So how you can say I have equation here? You can see, look at here, and how you can say, so like a this is the information, because that's what modulating signal where it is present. There should be information here. Omega m is not there. Omega m term is there. And look at this amplitude of carrier. Now, shall I say it will vary according to this frequency? According to this particular frequency. So therefore now, so what we're having in the carrier, the amplitude of the carrier now will vary as that of modulating signal. So what I did, the song which I wanted to transmit, I'll convert that into electrical signal. That electrical signal is put in the carrier wave, and there it's available as change in amplitude. Now, what the antenna will transmit? The antenna will transmit this signal. And what is the carrier frequency? High frequency. High frequency, what will happen? The size of antenna will decrease. Good, no? Like size of antenna in mobile, how much it is there? Hardly visible. Because the reason is something around 300 megahertz is what they're using. A very high frequency. So the size of antenna will decrease here. Then next again, different radio stations, I'll allow different carrier frequencies. Then problem will be solved. No? This will be next. After this, what will happen? Twice it's available, so it's left to me. The receiver, I can tune it for this and this. I'll get the desired signal frequency. So like that, the signal will be sent. So what is that greeting card? Is what? Modulating signal. Envelope is this one. So greeting card, I'm going to put in envelope, and the envelope will be transferred. So what is the carrier? Carrier itself, which will carry the information in the form of change in amplitude. Okay, let's go for the plotting of graphs. I took sine, no, I took sine graph. So corresponding to sine only, let me show it. Same graphically. I'm showing that mathematical operation, what all we did. I'm just showing it graphically. Okay, there's a modulating signal and there's an amplitude AM minus AM. Next we have high frequency carrier wave. Okay, there's about the, I think some adjustments I'll made it. Okay, later on I'll do correct when I'm sending this. So this is AC minus AC. This is VC. So there's a time period T. So how the amplitude modulated wave should be? Already I shown. Okay, let me put it that one. So this amplitude carrier, no. So this AC you bring it this line. There's a method of drawing it. So what all we have AC, no. So show that AC, that one. Above that AC, it will fluctuate. So this is no. Actually, you should not draw a solid line. No? Please make books we have shown. Okay, nothing wrong, but don't go for solid lines. A sine cos doesn't matter. Don't bother. Books also sometimes sine they have plotted for cos. It doesn't matter. Okay, that blue color lines is what you have to show it here. I'll try cloning. Oh, not fitting. Okay, better let me draw it. Will you mathematically accept the curve should be like this only? I'm testing your trigonometry. The frequency will not change. What changes is like only the amplitude. Somewhere the frequency changes and later on I'll adjust it. So this we know this value is how much? This is AM, no? Sorry, AC it is. This AC. This value is AM plus AC. This is AC minus AM minus AC. So minus AC plus AM. If you want, you can avoid the lower part. It should exactly come here. For minus AC plus AM. Yeah, it should be. Okay, fine. So the low things I'll avoid. Huh? Some lot of confusion will be there. Okay, just we'll write only this one. No, okay, let's come for this. So there's a graph what we have. So what is this amplitude modulated wave? So it contains no information. In what form? Change in amplitude. So looking at this graph, so we should define that modulation index. What is the modulation index? I wrote it like a AM by AC. And when it is propagating, so there's a maximum value of AM, no? What is the maximum value of amplitude modulated signal? So shall we take this as A max, and the minimum is this one. And modulation index, how we defined? AM by AC. So what is that AM plus AC looking at the graph? A max should be AM plus AC. I'll derive it nearby diagram only. And what is A minimum? AC minus AM. I'll add up these two. A max plus A minimum should be equal to 2AC. So what is AC is equal to? A max plus A minimum by 2. This value of AC, I'll substitute in either any one equation. A max equal to so if I solve this, I'll get AM is equal to A max minus A minimum by 2. Now this is what these two are only available. Rest all everything what happened? The mathematics what we did here. Okay, well, how is modulation index? We define that as AM by AC. Okay, I'll come for now the real meaning of that one. So modulation index is also called as depth of modulation. So what is the mu? It is AM by AC. According to the definitions what we got AM and AC. A max minimum by 2 A max plus A minimum by 2. Or this is, now you could ask questions of what is this? What is use of this? Okay, let's go for that envelope greeting card. I think that there's a best example is what analogy I'm telling, not better say example. There's the best analogy. We have everything that one. So this is the information, no? The information. How nicely means like a how successfully have placed greeting card in envelope is a question mark. I should know that also, no? So what actually we did, we are no. So this is the information. I think all of you see that there's a modulating signal, there's a carrier wave, there's a amplitude modulated wave. I'll write in red color. There's a carrier wave. And what is this? There's a modulating signal. Okay, now, so what is the question like? What we did, we have now put the the low frequency model, the information in the carrier in the form of change in amplitude. Now, next question comes, did we put it correctly? Is it modulated properly? Means, did we put greeting card properly in envelope? If it is put properly in envelope, okay, fine. If you didn't put properly, then there's a problem. So like that, I need a check, no? Did it got modulated properly? Did it got modulated? Somebody has sent some link, I don't know, to me only. youtube.com watch v equal to NCAIGM from CO1 to me. I don't know what is the thing. Okay, no. So did I put the information properly in the carrier? So I should check that particular thing. Means now you can, so sir, you said like once we put greeting card in, it's over. The greeting card you may not have put openly. Maybe it is put partially if there's an envelope. If there's an envelope, maybe the greeting card, what we have placed it will be like this. So it's popping out. It has popped out here. So this is what happens here. So what is the correct thing? If there's a envelope, there's a greeting card and the envelope should cover it properly. No? So this called like a 100% successfully we did here. So like that, what happened? Is it the signal modulated properly or not? As be cross check. For that purpose, I'm bringing this one. When do you can say like a, it is 100% modulation means yes, the information is not lost. Everything is perfectly modulated. To measure that, what happened? We are bringing this modulation index. If mu equal to 1, we usually will go for percentage here. For mu equal to 1, what is the condition required here? A minimum should be 0. So for different values of mu, what will happen? How the graph will be? Means, did we put information properly? The answer is no here. Did we put information properly? Means definitely the answer is no. For different values of mu, the graph will be different. And when it will be, when it is 100%, when mu equal to 1, a minimum 0, then mu will be 1. If mu equal to 100% means, then open the information is properly put in carrier wave and the carrier is properly modulated. Means no information is lost. What do you mean by sir, no information? Suppose say like, I say, I'm going to wish my wife. Okay, how are you when you will come back? Instead of how are you, don't come back, then go on, no. It can happen. So I'm sending my information to my wife like, how are you when you will come back, that one. So if it's a 100% modulation, then the information S will be sent. Suppose if it is some, say like a 80%. How are you? When will the you will come back? When will be missing? Then if it is a 50% is there, how are you maybe missing? You will. CK. or A will be there, B, C will be missing. This is a 50%. Like this, what happened? The information will be lost here. With the 100% as the message, how are you when you'll come back? Finish over. 100% modulation. Like this, what happened? We'll be missing it. Then sometimes what happen? Answer like it can be more than 100%. No, it can happen more than 1%. When that will happen, when A max minus A minimum is greater than A max plus A minimum. In that case, what happen? The signal will become how are you? When will become do when don't when you will don't come back. Now why this don't has come? When you modulate more, unnecessary information you're adding. I think this 125% is the big trouble for me. How are you when you will don't come back? Or don't come back. That's all. Finish. If I put a comma, okay, these are the problems are there. So the information I think is very, very essential. No? If unnecessary information should not get added up, there's an unwanted information due to distortion. It is like this. If it's less than 100%, some information is lost. How are you? Nothing is there. You will, nothing will be there. So this information lost here, unnecessary get added up. So therefore, what should be the modulation? Should be 100%. What you are singing, that they should hear. They should not hear more than what you sing or less than that one. What I'm sending message, that should be displayed here. Is it okay? No? So there's a most criteria for the broadcasting. So now IPL matches are there. That one, he went for 6, and instead of 6, if you show that he got caught, big problem. No? For betting people is a big problem. For may not be for us, for betting people. Okay, like this, what happened? The information will never be compromised. So it's a very, very difficult thing. So all things have to be taken care. So what is the simplest way? What I should do now? Did I put information properly or not? Directly come and check the mu. I'll be having instruments which will measure A max and A minimum. And from that, I'll put in this formula. One instrument itself will be there in the radio broadcasting station where it will display mu. And one person will be there who will be checking this particular thing. Or nowadays, software is there. In FM stations everywhere, a software will be there where information did it put properly or not, we'll check it. Got the idea? No? So how the, so there's a basic idea of the modulation, depth of modulation or modulation index. Usually we express in percentage. Now, what about the graphs for different values of mu? How the possible graphs will be? Okay, just we'll have a sequence of graphs, then we'll get into other part of mathematics. I think till here, the books, they have winded up till here, just another one block diagram put, but for exams, for open competitive exams, we need all this. I'll adjust it this here only. Just we'll finish off this graphs and again we'll enter into some derivation part. First, let me draw it. This is the what we have black color line. Small diagrams, I'll go for it. It will take more time, bigger diagrams. Okay, there's a carrier wave. Okay, for different values of mu, now we'll show the amplitude modulated wave. First one, mu less than 1. No? Rough diagram, you can refer to the books for still more better diagrams. This is for mu less than 1 or mu around 0.9 like that. For mu equal to 1, may not be up to the scale, a little bit I'm finding very difficult. Look at a minimum. A minimum has become 0. Are you noticing that? Now, there's a very popular way of, till now they didn't ask in mains, possibility of asking for different values of mu, what should be the possible graph? The frequency will never change in amplitude modulated wave. Though it's diagram, different frequency I'm showing. And this is for this is VC, amplitude modulated wave. This is mu equal to 1. A minimum is 0. You can see from clearly here. Here A minimum, I think there's a best way of for you to that one. So it happens that A minimum will become negative. A minimum will become negative. So I'll take the last one. not zero. It is, in fact, it's a negative, and the graph will be like this, the resultant graph. Where the A minimum will be negative will come and the mu will be greater than 1. So there's a distortion. Distorted AM wave. So what about this? Perfectly modulated or no information lost.